Before there was light, there was only silence. A silence so deep that even the very concept of sound did not yet exist. Within this void, a cold cloud of gas and dust stretched for trillions of kilometers, made of fragments left behind by stars that had died billions of years ago. It was an invisible ocean of hydrogen, helium, carbon, and iron, the same elements that would one day form the sun, the planets, and everything we call life. This cloud slept in equilibrium until something, perhaps the collapse of a nearby star, disturbed its rest and unleashed the birth of chaos. Gravity began to act silently, pulling every particle toward the center. As density increased, heat grew. Millions of years passed, and the core of this immense cloud began to glow. It was the birth of the sun. What had once been interstellar dust was now becoming the beating heart of a new system. Around it, the remaining material spun in a vast flat disk, where fragments of rock, ice, and metal collided endlessly, fusing into ever larger bodies. There, amid this cosmic storm, the first planets were taking shape. Each collision was an explosion. Each impact, a new fusion. The heat from the shocks turned metal into magma, and space filled with incandescent fragments. Matter was organizing itself under the force of gravity, and small worlds emerged like embers floating in the dark. The solar system, still in its infancy, was a battlefield. What we now know as Earth was then only a planetary embryo, spinning around the sun amid a swarm of wandering bodies. Its face was incandescent, its mountains were waves of fire, and its surface boiled under temperatures so high that no solid could last for long. Amid this primordial chaos, the young planet grew. Each impact increased its mass, its gravity, and its internal temperature. Iron and nickel sank toward the center, forming the metallic core that would one day protect Earth with a magnetic field. Above it, the mantle and crust slowly began to differentiate, though they were still liquid and unstable. The sky did not exist as we know it. There was no atmosphere, no air, no blue, only a red diffuse glow emanating from the boiling magma. The sunlight was weak, scattered by the clouds of dust that still dominated the surrounding space. In that scenario, time moved at a different rhythm. 1,000,000 years could pass like a cosmic blink. The first heavy elements mixed into new chemical combinations. Volatile compounds, such as water and carbon dioxide, were brought by asteroids and comets that collided with the forming planet. With each new impact, part of these elements vaporized, but another part sank deeper, creating the chemical foundations that would, in the future, give rise to oceans and atmosphere. The young Earth spun at a breathtaking speed. A full day lasted only 4 hours. This dizzying rotation caused the planet to deform slightly, flattening at the poles and stretching along the equator. The internal heat was so intense that rivers of magma flowed across the surface like fire streams. Volcanoes expelled gases, rocks, and metals in a constant cycle of destruction and creation. And around it, a dangerous dance was forming, a series of smaller bodies orbiting the sun, repeatedly crossing Earth's path. One of them would become the most important of all, Theia, the planet that would change the destiny of life. Before its encounter with Theia, Earth was only a body without stability. Its tilt shifted unpredictably, its climate was extreme, and its crust was as thin as glass over an ocean of magma. There was no balance yet, no order. It was a world born of fire, still searching for purpose. Beyond it, the solar system boiled with similar collisions. Mercury, Venus, Mars, all were being sculpted by the same process of creative destruction. But among them all, only Earth carried the secret ingredient that would make something unprecedented possible, the birth of life. The universe is never in a hurry. Each transformation required entire eras of waiting. For tens of millions of years, the young Earth was struck, melted, cooled, and struck again. With every new catastrophe, it emerged transformed, denser, hotter, more defined. Gravity gathered the dispersed fragments and molded them anew, as if the planet were learning to be solid. And when it seemed that chaos was beginning to fade, a new event approached. A body the size of Mars, traveling on an almost identical orbit to Earth's, ready to collide and change everything forever. It was the prelude to a cosmic fusion. The universe silent was preparing one of the most decisive moments in all planetary history. The encounter between Earth and Theia would not be just a collision, but a total transformation. And from the ashes of that impact, something new would arise. A companion, a guardian, the Moon. Before the impact that would change the destiny of Earth, The planet was a place without limits. A blazing sphere wrapped in storms of fire, where the ground melted beneath its own feet, and the sky was a thick cloud of metallic vapor. The surface boiled at thousands of degrees, and the horizon shimmered like an endless mirage. Nothing moved in silence. The planet roared. Waves of magma ran like liquid oceans, and jets of molten rock rose into luminous columns, falling in flaming cascades over red plains. It was a world under construction, without seas, without mountains, without sky. Everything was heat, collision, and motion. Earth of that era spun in fury. A full day lasted only a few hours, and the sun rose and vanished before the heat had time to fade. The speed of rotation caused hypersonic winds to sweep the globe, carrying gases and incandescent dust. Space around it was filled with wandering rocks, planetary fragments, metallic blocks, and icy bodies moving in unpredictable orbits. From time to time, one of them struck the surface, releasing energy equivalent to millions of atomic bombs. Each impact reshaped the planet, melting entire regions, opening seas of lava, and mixing the elements that would form the mantle and the crust. The planet was still being sculpted by blows of fire. Beneath this liquid surface, Earth's interior went through a silent revolution. The heaviest metals slowly sank toward the center, forming the core. Molten iron and nickel created intense electrical currents, and from them arose the first magnetic field. It was the beginning of the natural shield that, billions of years later, would protect the planet from cosmic radiation and solar winds. Above the core, the mantle boiled in constant motion driven by heat and pressure. It was as if the entire planet breathed, a geological organism pulsing in cycles of destruction and renewal. But Earth still lacked an atmosphere as we know it. What surrounded the planet was a toxic veil, dense and heavy with gases expelled by constantly erupting volcanoes. Carbon dioxide, sulfur, and water vapor dominated the air. At times, the heat was so extreme that raindrops evaporated before touching the ground. Even so, little by little, the release of these gases began to form a thicker, gaseous layer. The vapor accumulated, reflecting part of the sun's heat and helping the planet gradually cool. The chemical balance that would define Earth's future was beginning to take shape, though still under extreme conditions. The solid crust, when it formed, was fragile and temporary. Each new impact destroyed and recreated it in an endless cycle. Yet small regions of stability began to appear, floating above the ocean of magma. These fleeting islands of hardened rock were the beginning of the first terrestrial surface. They moved, fractured, and merged, like plates floating on a liquid inferno. Beneath them, heat radiated intensely, causing continuous eruptions and explosions. Still, there lay the first seeds of the future continental crust, thin, fragile, but essential. In this extreme environment, something astonishing began to happen. Water brought by asteroids and comets started to accumulate in the cooler regions. Each impact of those celestial bodies released not only energy, but also ice molecules that turned into vapor, then into clouds, and finally into rain. It was an acid, dense rain, full of dissolved gases and minerals, but it marked the beginning of the water cycle. Millions of years of continuous precipitation turned valleys of lava into basins filled with dark, boiling liquid. The first oceans of Earth were born amid thunder and fire. Meanwhile, the solar system remained in full anarchy. The orbits of the young planets adjusted in a violent and unpredictable dance. Mercury, Venus, and Mars fought their own battles for stability. And among them, on an orbit close to Earth's, a body the size of Mars traveled through space like a silent shadow. It was Theia, a planet formed from the same material as Earth, born from the same stellar dust disk, but which had followed a slightly different path. For millions of years, their trajectories coexisted in fragile harmony, until the gravity of the Sun and neighboring planets began to slowly divert Theia's path toward Earth. The approach was slow, imperceptible, but inevitable. With each turn around the Sun, Theia moved a little closer. Its unstable orbit became increasingly dangerous, until the two worlds began to feel each other's pull. Gravitational forces started to slightly distort their shapes, as if space itself were bending between them. Earth reacted with stronger tremors and more violent eruptions, while Theia followed its silent course, moving toward a destiny that would forever change the history of the cosmos. At that point, Earth was a vulnerable body, Its crust was too thin to withstand a collision, and its inner structure was still not fully stabilized. The planet had just been born and had barely begun to mature. It was like a cosmic child growing in a stellar battlefield, and the universe, indifferent, was preparing what would be its greatest and most transformative impact, a meeting of titans that would merge two worlds into one. The collision with Theia would not be an accident. It would be an act of creation, a moment when destruction would bring balance, and from fire, harmony would be born. From that impact, Earth would gain an eternal companion, the Moon, and the primordial chaos would give way to the order that would make life possible. At some point in space, between the primitive orbits of Earth and Venus, a body began to grow. It was a young planet, formed from the same stardust that composed the rest of the solar system. In modern times it is called Theia, a name given to the Titan of Light in Greek mythology, mother of the Moon. Its origin was silent, shaped by successive collisions and by the slow gravity that gathered grains, stones, and metallic fragments into a growing sphere. Theia was born under the same forces that gave life to Earth, and perhaps that is why they were so similar, almost sisters, orbiting the Sun side by side on dangerously close trajectories. In the first millions of years, Theia was just one more among the many protoplanets wandering through the debris disk. The solar system was still a storm of rocks and gases, with orbits that changed after each collision. The giant planets, such as Jupiter and Saturn, moved slowly, disturbing with their gravity the paths of the smaller bodies. It was this motion that altered the balance of the inner orbits and pushed Theia toward Earth. For a long time, the two spheres coexisted in unstable harmony, separated by a thin cosmic distance. But that distance shrank with each era, and the strength of their mutual attraction grew like an inevitable call. Theia possessed a metallic core and a silicate mantle similar to Earth's. It was dense, hot, and geologically active. Had it survived, it might today be a habitable planet, with oceans and an atmosphere. But destiny reserved another role for it, to become the final ingredient in Earth's formation and the cradle of the Moon. Its orbit, slightly inclined and elliptical, began to cross Earth's. With each passage, tidal forces between the two bodies intensified, deforming their surfaces and releasing thermal energy. It was as if the space between them vibrated, preparing for the moment when their paths would align in a straight line. Modern astronomers have been able to recreate this event in detailed simulations. They show Theia approaching Earth at a speed of more than 30,000 kilometers per hour. At that point, the two worlds became unavoidably a single course. No force in the cosmos could prevent the collision. In only a few days, gravitational forces began to elongate Theia, stretching it as if it were made of cosmic clay. On Earth's side, the magnetic field distorted, and the mantle began to tremble. The gravitational tension was so intense that even before the impact, the entire planet reacted, as if sensing what was about to happen. But Theia was not just an invader. It was a reflection. The composition of its minerals was almost identical to Earth's, as if both had been born from the same matrix of cosmic matter. This similarity would explain, billions of years later, why lunar rocks would bear the same isotopic signature as terrestrial rocks. It is as if Theia were a lost twin, who instead of following its own fate, chose to merge with its sister to create something greater. The impact between the two was not only destruction, it was a unification. Before colliding, Theia had already experienced its own cataclysms. The energy of its internal formation was so intense that vast regions of its surface remained molten. Volcanoes and seas of lava marked its relief. Fragments of other smaller bodies, remnants of ancient collisions, probably orbited around it, like a small family of moons that would be destroyed in the final crash. Nothing about Theia was static. Its rotation was irregular, its orbit unpredictable, and its existence brief. On the cosmic stage, it was a secondary star destined to disappear, yet to leave forever the mark of its passage. As Theia drew nearer, Earth turned in silence. Its fiery horizon saw, night after night, a luminous point grow in the sky, the reflection of a planet coming to meet it. Perhaps, if there had been an observer at that time, they would have seen the glow intensify until it became an incandescent sphere crossing space. The distance between the two worlds diminished rapidly. Tidal forces began tearing fragments from Theia's outer layers, which scattered around Earth like burning dust. In a few hours, the collision path was traced. Gravity allowed no return, and then in the silence of space, history took a new course. Theia, the lost planet, was about to fulfill the role for which the universe itself had shaped it. A shock of such magnitude that it would fuse two worlds into one, creating the moon and redefining Earth's balance forever. What seemed like the end of a celestial body was, in truth, the beginning of something far greater, the birth of a binary system that would sustain the rhythm of life, of the tides, and of time. The collision began without sound, because in space there is no air for sound to travel through. The silence was absolute. Theia approached at a speed of more than 30,000 kilometers per hour, and as it entered Earth's gravitational field, its shape deformed like liquid clay. The pull of attraction drew it seas of magma, creating gigantic waves of molten rock rising on the planet's horizon. For moments that seemed eternal, the two bodies exchanged gravitational energy in a dance that could not be stopped. And then, at the exact point of intersection, Theia struck Earth. The impact was so violent that the energy released exceeded the sum of all nuclear explosions humanity would ever produce throughout its history. In a fraction of a second, the side of Earth that was struck completely melted. Theia's core penetrated the terrestrial mantle, merging with it. Entire mountains evaporated instantly. The entire planet trembled, and the material from both spheres was launched into space in an incandescent surge. Earth, until then almost spherical, deformed into waves of magma and gas. The impact did not destroy the planet. It reshaped it. Incandescent fragments were hurled into orbit, forming a ring of debris that circled the globe. They were billions of tons of molten rock, metallic vapors, and shining dust. Earth's sky became a luminous vortex. For hours the planet remained in total turmoil. Portions of the mantle were expelled thousands of kilometers away, and as they cooled, began slowly merging into solid clusters. This glowing dust spinning around Earth would, over time, become the cradle of the moon. Inside the planet, Theia's iron and nickel core sank and integrated into Earth's core. This process increased Earth's density and reinforced the magnetic field that, millions of years later, would protect the planet from solar storms. It was the birth of a stable, heavier, and more resilient structure. The impact, though destructive, gave Earth a new physical and chemical identity. It was as if the collision had redefined the planet's internal balance, fusing two geological histories into one. On the outside, the surface remained molten. For centuries, the planet shone like a red star, visible from great distances in space. The heat radiated by the impact was so intense that the magma ocean formed a temporary atmosphere of vaporized rock. Temperatures reached thousands of degrees, and winds carried liquid metals like mist. Sunlight barely pierced the glow of the incandescent planet. It was as if Earth had been reborn under a halo of fire. The ring of debris continued to orbit the planet. Over time, the fragments began colliding with one another, fusing into larger blocks. Gravity united the pieces, transforming chaos into order. This process took millions of years, but the result would be a solid sphere orbiting Earth, the Moon. At first it was very close, perhaps only 20,000 kilometers above the surface, occupying a vast portion of the sky, so immense that it dominated the night and bathed the planet in golden light. Earth, still unstable, spun rapidly, and the tidal force between the two bodies was colossal. The energy generated by this interaction began to slow Earth's rotation and gradually push the Moon farther away, a motion that continues even today. Each passing day became slightly longer, and the Moon a bit more distant. What began as destruction evolved into gravitational harmony. Two bodies, made of the same matter, now bound by an invisible and eternal force. As the heat began to subside and the magma started to solidify, the planet transformed. New crusts formed, thicker, stronger. The gases released during the impact helped build a more stable atmosphere, and volatile elements like water vapor began to condense. Millions of years later, what remained of this cataclysm would become the foundation of the oceans and Earth's climate. The impact of Theia did not merely create the Moon, it recreated Earth itself. The universe seemed to have used the force of destruction as a tool of balance. Theia vanished as an individual body, but remained alive, part of it within Earth, part of it in the night sky. Since then, the Moon has orbited silently, reminding the cosmos that even the greatest collisions can give birth to beauty and stability. The day the moon was created was also the day chaos became order. For a long time, Earth remained surrounded by a ring of fire. They were fragments of molten rock, metallic vapors, and luminous dust spinning at high speed. That incandescent crown stretched to the limit where Earth's gravity could still hold dominion over matter. Seen from afar, those remnants looked like a bright ring, similar to Saturn's, but made of embers. The light that emanated from it reflected on the magma of Earth's surface, turning the planet into a double furnace, Earth and its ring of fire spinning together in the darkness of space. Every particle in that ring carried energy and motion. They collided, shattered, and fused without pause. The larger ones attracted the smaller, and little by little chaos began to condense into solid blocks. This process, guided only by gravity and time, transformed millions of scattered fragments into an ever more cohesive body. What had once been burning dust became an incandescent sphere, the newborn moon. It arose from fire not as a flash, but as a slow condensation, a cosmic birth that lasted for centuries. In the earliest times, the moon was colossal in the sky. It was about 20 times closer to Earth than it is today. Its apparent diameter was so large that it occupied almost half the horizon. At night, it cast upon the planet a reddish glow, the reflection of the still liquid magma on its surface. Earth, in turn, seen from the moon, was a spectacle of light and motion, a flaming sphere covered by storms of fire and metallic clouds. It was a pair of newly formed worlds, bound by an indissoluble gravitational bond. The young moon was a solid inferno. Its crust was still forming, and vast seas of lava covered much of its surface. Every drop of magma that solidified left scars that, billions of years later, would still be visible as dark plains known as lunar seas. In its interior, the heat was intense enough to drive periodic eruptions that hurled gases and particles into space. There was no air, no wind, only silence and light. It was the birth of a body that would one day become the symbol of calm and stability, yet began as a flame. Meanwhile, the parent planet still boiled. The heat of the impact kept Earth in a liquid state. The tidal forces created by the moon's proximity were so intense that they made the magma rise and fall in gigantic waves. Each oscillation released energy, helping the planet shed heat more quickly. This motion, repeated for millions of years, slowed Earth's rotation and pushed the moon slowly away. Each terrestrial day became longer, and each night darker. The growing distance between the two bodies allowed the system to find stability. Over time, the lunar surface began to cool, the crust solidified, and eruptions became less frequent. The reddish glow gave way to grey and silver tones. Craters, formed by meteor impacts, began to mark its skin forever. The moon became Earth's silent mirror, cold, stable, and unchanging. The energy that had once been chaos turned into gravitational balance. The moon began to rotate in a synchronized way, always showing the same face to the planet that created it. This phenomenon, called tidal locking, is what allows us to see only one side of the moon to this day. Earth changed as well. As the moon receded, the gravitational field between the two diminished, and the giant tides were replaced by gentler cycles. The planet stabilized on its axis, and the climate began to become predictable. This stability would be crucial for the emergence of oceans, of seasons, and later of life. The impact that had been destructive at first had become the engine of harmony. In space, the glow of the cooled moon reflected sunlight for the first time. It was the beginning of the alternation between day and night as we know it. Earth's sky, once shrouded in vapors and ash, began slowly to clear. For the first time, the planet's molten surface saw the soft light of moonlight. The moon, born of fire, now illuminated the world's cooling. For billions of years that relationship endured. The moon drifted away by about 4 centimeters per year, yet the bond between the two bodies never broke. Tidal energy continues to shape the planet, governing the oceans, biological rhythms, and even the behavior of living beings. Everything we know, the cycle of the tides, the regularity of climate, the length of days, is a direct inheritance of that instant of collision. The incandescent moon gave way to the serene moon, chaos became balance, and fire gave birth to light. The universe in silence, witnessed the birth of a cosmic partnership that would shape Earth's destiny forever. From that moment on, the planet was no longer alone. It had an eternal companion, born from the same impact that almost destroyed it. Earth and the Moon were born from the same cataclysm, and since then, their trajectories have remained bound by an invisible link. The gravitational force between them formed a binary system, two bodies orbiting a common center of mass, locked together in a balance so delicate that the slightest variation would be enough to undo the harmony. But the universe chose balance, and that balance, silent and persistent, shaped the destiny of both. In the first millions of years after the impact, the Moon orbited incredibly close to Earth. In just a few hours, it completed a full revolution around the planet. The gravitational tides generated by that proximity were of unimaginable violence. Earth's magma rose and receded in giant waves that swept across the entire globe. Each oscillation released heat and energy, transforming the planet's rotation. Earth spun like an unstable top, and the presence of the Moon acted as a gradual break. With each cycle, the rotation became slower, and the days began to lengthen. This exchange of energy between the two bodies is the heart of the Earth-Moon system. The tidal force that the Moon exerts on the planet pulls the oceans and solid masses, creating subtle yet constant deformations. In response, Earth returns part of that energy, pushing the Moon into a slightly more distant orbit. Thus, while Earth's days slowly lengthen, the Moon drifts a few centimeters farther away each year. This process, almost imperceptible, has been happening for billions of years and continues today. It is the slow movement of the cosmic dance that keeps the two bodies in perfect resonance. But the Moon did more than slow the planet's rotation. It stabilized Earth's axis of rotation. Without its presence, the axis would wobble chaotically, causing the seasons to shift unpredictably. There would be eras of extreme heat, followed by centuries of absolute cold. With the Moon, the axis remains constantly tilted at about 23.5 degrees. This stable inclination allows for the regular alternation of seasons, the balanced distribution of sunlight, and the moderate climate that made life possible. The Moon is therefore the counterweight that prevents Earth from becoming a wandering planet, lost in its own imbalance. As Earth cooled, the presence of the Moon also influenced winds, ocean currents, and the very formation of the first tides. Gravitational forces created cycles that stirred the waters, mixing minerals, gases, and chemical elements. These cycles would be fundamental, millions of years later, for the emergence of the first organic molecules and the development of life. The simple fact that the planet has such a large satellite relative to its size was decisive for its climatic and biological stability. The Moon also served as a natural shield. Its mass and gravity altered the trajectories of countless asteroids and comets that crossed Earth's orbit. Many of those bodies were drawn toward the Moon and struck its surface, leaving craters that still cover its face today. Without it, many of those impacts would have reached the planet, perhaps destroying the fragile conditions that allowed life to appear. Each lunar scar is, in truth, a reminder of the dangers Earth escaped by being protected. As time passed, the binary system began to take its definitive form. The Moon gradually moved away, and Earth, once spinning at a frenetic pace, began to turn more steadily. The heat of the initial impact dissipated, and the planet started showing signs of balance. The crust solidified, volcanoes became less frequent, and the atmosphere, once toxic, began to hold enough water vapor to form real clouds. When the first rains fell upon the planet, they met a Moon that already shone calmly in the sky, cold, silent, and ever-present. Over billions of years, this gravitational relationship shaped the fate of both. The Moon, now locked in synchronous rotation, always shows the same face to Earth. This phenomenon, called tidal locking, is a direct result of the energy exchange between the two bodies. The same process that slowed Earth's rotation caused the Moon to lose its freedom to spin independently. It remains eternally turned toward the planet that created it, as if trapped in an endless gaze. Today, the balance between the two bodies continues to define the fundamental rhythms of life. The tides, the cycle of day and night, the climate, the winds, and even biological behaviors follow the cadence established by this connection. The Moon, born of fire, has become Earth's metronome. With every night it rises in the sky, the planet relives a distant echo of that original impact. a silent reminder that in the cosmos, destruction can be merely the beginning of a new form of order. The impact was over. Cosmic dust began to disperse, and for the first time, Earth could breathe. The planet, still hot and wounded, turned slowly under the soft glow of a colossal moon that dominated the sky with its reddish light. The intense heat from the collision with Theia kept escaping from the planet's interior in streams of incandescent magma. But little by little the fire gave way to rock, and the surface began to stabilize. The world that had once been a furnace of molten metal now became a solid body, wrapped by gases that would, with time, form the atmosphere. The first rains fell while the moon was still close enough to turn the tides into true liquid mountains. Acidic drops, formed by water vapor mixed with sulfur dioxide and carbon dioxide, fell upon the hot crust and turned instantly into vapor. But with gradual cooling, water began to persist. Each succeeding rain lasted a little longer, and each drop evaporated a little more slowly. For millions of years, the cycle repeated until the depressions in the crust filled with liquid water. Thus the first oceans were born, warm, dense, and deep. The moon, still nearby, pulled these liquid masses with colossal force. Tides rose by hundreds of meters, dragging minerals and ash toward the lower regions. The friction generated by this constant motion helped warm Earth's interior, while the cycles of rising and falling mixed the chemical elements dissolved in water. This ceaseless back and forth was the planet's first breath, a rhythm created by lunar gravity that would, much later, give rise to the first biological cycles. As the eras passed, Earth's crust became thicker and stronger. Volcanoes still roared, expelling gases and minerals, but the planet now began to develop a resilient skin. Eruptions hurled carbon dioxide and water vapor into the atmosphere, and these gases, upon condensing, fed new rains. The water cycle, born from chaos, began to regulate the climate. The moon, like a gravitational metronome, kept the balance of the tides and stabilized Earth's rotation, ensuring that the sun's heat was distributed more evenly. While the planet calmed, the moon became ever colder. Its solid surface reflected sunlight in a pale glow that lit Earth's night side. Under that light, the planet began to show a new face. Rivers of lava became valleys, craters turned into basins, and solidified magma gave rise to mountains and plains. The contrast between fire and water created new minerals, new chemical combinations, new soils. It was the beginning of terrestrial geology as we know it. The tides, once violent, began to become regular. Instead of waves of destruction, they became pulses of life. The movement of the waters spread heat, distributed sediments, and created pockets of calm between storms. Those refugees would be, millions of years later, the cradle of the first organisms. The moon not only shaped the planet with its gravity, it also shaped the environment that would one day shelter biology. In the sky, the spectacle was indescribable. The moon, still close, swept quickly from one side of the horizon to the other, completing its phases in only a few days. Its light, reflected upon the newly formed ocean, created patterns of brightness and shadow that changed every night. It was Earth's first natural calendar. Lunar phases marked time long before there was any being capable of perceiving it. Meanwhile, the atmosphere transformed. Constant rain washed the air, removing part of the carbon dioxide and toxic gases. Water vapor gathered into thick clouds, and the planet, once wrapped in a reddish glow, now showed bluish and gray tones. The first lightning split the sky, producing electrical discharges that reacted with atmospheric gases to generate complex chemical compounds. Earth was ready for a new chapter, the emergence of organic molecules that would give rise to life. For millions of years, the planet breathed in this rhythm, guided by the moon's force. With each oscillation of the tides, the crust shifted, the atmosphere changed, and the oceans deepened. The sun's heat, combined with lunar influence, created a choreography that united fire, air, water, and rock in a single beat. Earth ceased to be merely a solid body and began to behave like a living system, a planetary organism that regulated itself. And high above, the moon watched, motionless in appearance, yet in constant motion, drifting away little by little, as if giving the planet space to mature. Its cold glow was the reflection of calm after cataclysm. It had been born from fire, and now guided the cooling of the world. Under its light, Earth learned to breathe, to spin in balance, and to store what would become the planet's lifeblood: water. The planet and its satellite already formed an inseparable pair, one body sustaining the other in a slow and silent dance that would last for billions of years. The impact of Theia left deep scars, but it also bestowed the gift of stability. From that point on, chaos began to turn into harmony, and the universe for the first time witnessed the emergence of a world ready to harbor life. When Earth's oceans calmed and the heat from Theia's impact finally dissipated, the planet entered a new era. It was the time of humid silence, the beginning of the chemistry that would precede life. The dark, lukewarm waters of the primordial seas became true natural laboratories, where the gravitational forces of the moon played an invisible but fundamental role. The moon, which had once shaped the body of the planet, was now shaping its biological destiny. Its tides, once destructive, became a precise cycle of motion and rest, a pulse that drove chemical reactions and gave rhythm to the transformation of matter. The tides, created by the moon's gravitational pull, moved immense quantities of water, carrying dissolved minerals and simple organic compounds across coasts and shallow basins. With each rise, these materials were mixed, heated by solar radiation, and exposed to ultraviolet light, which broke and rearranged molecules. When the tide receded, it left behind isolated, concentrated pools where elements reacted more intensely. This cycle, repeated for millions of years, was the planet's first great chemical experiment. In those salty pools, under sunlight and the constant influence of the moon, arose the first stable combinations of carbon, hydrogen, oxygen, and nitrogen. The electrical energy of lightning, the heat of the tides, and the force of evaporation created an endless sequence of reactions. Amino acids, sugars, and complex compounds began to form. In some regions, oily films coated the water's surface, and tiny bubbles of self-organizing molecules appeared and vanished. These fragile, ephemeral structures were the precursors of cells. They were not alive yet, but they already showed the first hint of something new: the ability to organize and respond to the environment. The moon, with its regular cycle, provided the ideal cadence for this process, the exact timing of exposure, mixing, and isolation. During this period, the entire planet functioned like a vast chemical lung. The tides became the pulsing heart of the young Earth, generating constant movement. The back-and-forth motion of the waters carried nutrients, distributed heat, and kept the surface active. Without the moon, these variations would have been minimal, and the chemistry of life would have remained stagnant. It was the alternation between ebb and flow that created the conditions for inert molecules to gain complexity. The first chemical DNA, still lifeless, emerged in silence on the shores of a planet, breathing to the rhythm of the moon. The moon's gravitational effect also helped stabilize the climate and the length of days, essential factors for life's emergence. Longer, steadier days allowed mild temperatures to persist, and variations in light created alternating patterns of brightness and darkness. This cyclical oscillation would become one of biology's cornerstones, the circadian rhythm. From the first molecules to modern organisms, every form of life on Earth would forever carry this lunar imprint, an invisible inheritance written into its genes. As the oceans grew more stable, regions of transition between land and sea appeared, shallow coastal zones periodically flooded by the tides. These frontiers between water and rock were cauldrons of transformation. Heated minerals, metallic salts, and organic compounds combined to form increasingly complex structures. The moon, by pulling and releasing the waters, created intervals of air exposure that allowed new chemical reactions to occur. Thus, the first molecular chains could replicate, absorb energy, and finally begin the process that would culminate in cellular life. Over time, these simple structures multiplied and evolved. Microorganisms began to harness solar energy, releasing oxygen and transforming the atmosphere. The planet shifted from a dark, suffocating world to one filled with air and light. This entire process depended on the climatic stability and rhythmic cycles maintained by the moon. Without it, Earth's rotation would have been erratic, the climate unpredictable, and the tides nearly non-existent. Life, if it had ever arisen, might never have found enough constancy to thrive. Lunar influence extended beyond chemistry. The moon's glow on cloudless nights guided the behavior of the first organisms, influencing reproductive cycles and migration patterns of aquatic species. The reflected light on the ocean acted as a natural clock, determining the ideal moments to feed, hide, or reproduce. Even today, millions of species follow the rhythm imposed by the moon, from coral growth to sea turtle nesting. It is a biological echo of the ancient bond between the seas and the satellite that moves them. Every drop of the ocean carries that memory. Every living being holds, within its genetic code, the mark of that primitive cycle. By stabilizing the planet and governing the tides, the moon not only shaped Earth, but also created the stage where life could arise. It is impossible to separate biology from astronomy, because the origin of life is, above all, a cosmic story. The moon is not just a celestial body in the sky, it is the metronome of life on Earth. And so, the planet that was once forged by fire now pulsed under the rain of water. Earth had transformed from an incandescent sphere into a blue world, and the moon, born from destruction, had become the guardian of balance. The impact that seemed to mark the end of two worlds revealed itself as the beginning of one, the world where life would learn to exist. Life had begun as a chemical reaction on the shores of the primordial seas, but soon it became a biological symphony. Microorganisms multiplied in the warm waters, and Earth, which had once spun in silence, now pulsed with millions of microscopic cycles. Behind each one, invisible and constant, was the influence of the moon. The same force that had shaped the planet and pulled the tides now guided evolution, dictating the rhythm of growth, reproduction, and survival. From the simplest life forms to complex creatures, everything followed the tempo set by that distant body, born from an impact billions of years ago. In the primordial oceans, the ebb and flow of the tides created an environment of perpetual change. Organisms that learned to adapt to these oscillations had a better chance of surviving. Thus arose the first strategies of resistance, the first biological behaviors tied to time and place. Some beings developed membranes capable of withstanding periods out of water. Others learned to move to the rhythm of the tides to seek food and shelter. The moon, without ever touching the sea, determined who lived and who perished. As the ages passed, moonlight became another evolutionary factor. Bright nights created periods of activity for predators and prey. Marine species adjusted their feeding and reproductive cycles according to the luminosity reflected on the ocean. Many organisms still reproduce in synchrony with the phases of the moon, a behavior inherited from times when sky and sea spoke the same language. Biology learned to read moonlight as a natural calendar, and the genes of the oldest creatures kept that information as a secret code that crossed eras. When photosynthesis emerged, transforming solar energy into food, the moon's presence continued to play an essential role. The tides kept the waters in motion, mixing nutrients and oxygen, and preventing the oceans from becoming stagnant environments. Constant movement spread life, and photosynthetic organisms began to transform the planet. The oxygen they released changed the atmosphere forever and made new forms of life possible. All this once again took place under the moon's influence, which continued to regulate tidal cycles, ensuring a balanced distribution of nutrients. With the rise of oxygen, life left the seafloor and began to occupy coastal zones. At the margins, the moon still set the pace. Amphibious organisms needed to synchronize their movements with the tides so as not to be trapped in isolated pools or swept back to the sea. Survival depended on understanding lunar time, and evolution rewarded those that could anticipate the rise and fall of the waters. Thus, the first temporal instincts were born, the sense of rhythm and predictability that would later give rise to the biological awareness of time. Lunar influence was not limited to the waters. Over the ages, as the moon drifted away and Earth's climate became more stable, nightlight continued to serve as a guide. The first forests formed under that cycle, and the alternation between day and night began to regulate leaf opening, flowering, and the behavior of insects and animals. The moon created a second beat within nature, an intermediate time between the solar day and the annual cycle of the seasons, a silent biological clock governed by its constant presence. For hundreds of millions of years, the moon accompanied the planet's great transformations. It witnessed the emergence of fishes, amphibians, and reptiles. It watched the forests of giant ferns and the seas teeming with prehistoric creatures. When the world was shaken by mass extinctions, the moon remained there stable, preserving the memory of a changing planet. Its gravitational influence kept Earth's axis balanced, preventing extreme climatic swings that could have erased all life. Without this stability, the planet would have experienced catastrophic oscillations, permanent glaciations, or fatal warmings. The moon also played a decisive role in the ages that followed, when life began to become conscious. The rhythm of the tides and the cycle of lunar phases served as orientation for the first social species. Turtles, corals, and fish developed synchronization with lunar brightness to guarantee collective reproduction. This behavior was passed down from generation to generation until it became part of instinct. Even millions of years later, the legacy of that pattern is still present. The moon, with its predictable cycle, became the planet's first natural clock. When the first mammals and birds appeared, lunar influence continued to act. Modern studies show that many animals regulate their hunting, sleep, and migration according to the moon's brightness. Wolves howl beneath its glow not by chance, but by evolutionary tradition, because their ancestors learned that the illuminated night was the ideal time to move and communicate. Likewise, nocturnal tides continued to determine the behavior of marine creatures, creating life patterns that spanned generations. And then, the human being arose. Even before understanding what he saw, humanity looked to the sky and recognized the moon as something constant amid change. It marked the time of harvests, hunts, and reproduction. It guided the rhythm of the tides, and with them, fishing and navigation. It became symbol, measure, and mystery. But the bond was much older than any civilization. It was genetic, engraved in life's origins. Human beings, without realizing it, continued to follow the tempo it had set from the beginning. Thus, the moon, born from an impact that nearly destroyed Earth, became the silent mentor of evolution. Every evolutionary leap, every climatic shift, every reorganization of ecosystems occurred under its influence. It was the planet's clock, guide, and mirror. And as Earth became a home for biological diversity, the moon watched in silence, fulfilling the role the cosmos had assigned it, to transform the initial chaos into living harmony. From the instant it was born of the impact with Theia, the moon became more than Earth's companion. It became its silent guardian. In space, where stability is rare and chance rules, the presence of such a large satellite made Earth a singular planet. The gravitational force binding the two bodies acts like a cosmic anchor, preventing the planet from veering off its axis and plunging into fatal climate cycles. The moon, with its constant presence, softens the universe's excesses. Without it, the balance that sustains life would be impossible. Earth's rotation is not static. It wobbles slightly, like a top about to tip. These wobbles, called precessions, alter the tilt of the axis and therefore the way the sun distributes light and heat throughout the year. The moon acts as a counterweight, keeping that tilt stable at about 23.5 degrees. That constancy creates the predictable rhythm of the seasons. If the moon did not exist, Earth's axis could swing violently, tilting to 40 degrees or more. Under such conditions, polar areas would become deserts, and tropical regions could freeze. Entire civilizations would never have arisen, and complex life might never have found the stability needed to evolve. But lunar protection goes beyond axial tilt. It also acts as a gravitational shield against the solar system's chaos. Jupiter and Saturn, with their colossal masses, perturb the orbits of smaller planets and asteroids. Without the moon, those forces could affect Earth's rotation, lengthen days, accelerate tides, and trigger extreme climate variations. The satellite's presence creates a field of resonance that stabilizes the planet's motion, smoothing external gravitational effects. It is an invisible choreography that prevents Earth from becoming a wandering body in space. During the great eras of bombardment in the first billions of years, the moon served as a physical shield. Thousands of asteroids that might have struck Earth collided with it instead, leaving deep marks that still cover its surface. Every lunar crater is a memory of a disaster that did not happen here, the visible record of countless times the moon stepped between the planet and destruction. Even today, its presence continues to deflect smaller objects that cross Earth's orbit, reducing the frequency of catastrophic impacts. That protection was crucial during life's development. Earth's thermal balance depends not only on the sun, but also on the regularity with which solar energy is absorbed and reflected. The moon influences tides and ocean currents, which in turn redistribute heat across the planet. When the sun overheats the equator, marine currents, guided in part by tides, transfer warmth toward the poles, balancing the global climate. Without this mechanism, Earth would have zones of permanent heat and endless frozen regions. The planet would be inhospitable and unpredictable, with far more frequent mass extinction cycles. The moon also acts as a regulator of day length. With each passing century, the gravitational interaction between the two bodies lengthens Earth's day by a fraction of a second. This slow, steady increase contributes to thermal and biological stability. Daily rhythms of light and darkness remain in step with life cycles. If Earth spun too fast, there would be incessant winds and abrupt temperature shifts. If it spun too slowly, one hemisphere would freeze while the other burned beneath the sun. The moon ensures the planet turns at the right tempo, neither too fast nor too slow. On larger scales, the moon also influences glacial and interglacial periods. Small variations in Earth's orbit and tilt, known as Milankovitch cycles, determine the onset and end of ice ages. The axial stability guaranteed by the moon makes those variations gentle and predictable. Thus, the planet never plunges into irreversible extremes. With each new glacial era, life has time to adapt, evolve, and be reborn. In a sense, the moon is Earth's geological metronome, marking the beat of its deep cycles, controlling the pulse of the ages. Even in catastrophes it could not prevent, the moon served as witness and mediator. When an asteroid struck Earth 66 million years ago, ending the age of the dinosaurs, the moon watched from afar. Its presence kept the axis stable and prevented the planet from losing thermal balance after the impact. Without it, tilt variations might have worsened the destruction, perhaps preventing the rise of mammals and, consequently, of human beings. The moon does not merely light the night, it ensures that the following day exists. Over time, the moon became part of the planet's very identity. No other known world has such an intimate relationship with its satellite. Mars has small, irregular moons. Jupiter and Saturn have dozens, but all are distant and cold. Only Earth has a satellite that stabilizes its climate, influences its geology, and shapes its biology. It is a rare, almost poetic partnership between two bodies born of the same impact. The moon is literally Earth's mirror, made of the same matter, born of the same fire, destined to accompany the planet to the end. As centuries turned into billions of years, the moon continued to fulfill its silent role. Every tide, every season, every heartbeat of the climate cycle bears its signature. It does not merely observe, it participates. The moon is Earth's invisible guardian, the architect of the stability that made the improbable possible, the existence of life on a small blue dot adrift in space. The impact that gave birth to the moon did not end when the dust settled. It remains alive, recorded in the deep layers of Earth, in lunar rocks, and in the planet's internal structure itself. Every fragment of mantle, every chemical trace, and every mineral difference between Earth and moon tells the same story, that of an event that redefined the geology of two worlds. The collision between Earth and Theia not only shaped the crust, but merged their very essences. From that moment on, both ceased to be independent bodies and became complementary parts of a single system. For billions of years, the evidence of that impact remained hidden beneath the surface. But as science advanced, subtle signs began to emerge. Samples of rock brought back from the moon by space missions revealed compositions nearly identical to Earth's, especially in the isotopes of oxygen, silicon, and titanium. The similarity is so precise that it would be highly unlikely if the moon had formed elsewhere in the solar system. The only coherent explanation is that it was born from Earth's own body, mixed with fragments of Theia. The moon is therefore the physical memory of a collision that fused two worlds. For a long time, it was believed that Theia had been completely absorbed, but recent studies suggest that part of its mantle may have survived inside Earth. Seismic research has revealed the existence of two gigantic dense regions in the lower mantle, located beneath Africa and the Pacific. These formations, known as large low shear velocity provinces, appear to have a composition distinct from the rest of the planet. They are so ancient and resilient that some geologists believe them to be fragments of Theia, the last remains of the planet that collided with us about 4,500,000,000 years ago. These structures are not simple geological irregularities. They influence mantle behavior and may be responsible for the locations of supervolcanoes and hotspots in the crust. In other words, Theia still shapes Earth's geology from within. The impact not only blended the planets, it created a fusion that continues to express itself in every eruption, every tectonic shift, and every tremor that shakes the ground. The planet carries within itself the remnants of its creator and destroyer. The Moon, in turn, preserves the record of everything Earth has lost. Without atmosphere or erosion, its surface retains the scars of the solar system's first billions of years. Every crater is an archive, every dark plain a testimony of the past. The absence of erosion makes the Moon a time capsule, the only geological mirror of what Earth was in its youth. While wind and rain erased Earth's early history, the Moon kept alive the memory of our origins on its silent skin. Space missions have revealed something deeper still. The Moon's interior is surprisingly dry, indicating that its formation occurred at extremely high temperatures, consistent with a colossal impact event. Small amounts of water have been found trapped in crystals within lunar basalt, suggesting that some of Earth's volatiles survived the collision. This confirms that the impact did not completely destroy the elements that would later sustain life. Even amid fire, a part of the planet preserved the seeds of survival. Other analyses show that the Moon's core is small and dense, composed of iron and sulfur, a reduced version of Earth's own core. This structural parallel reinforces the idea that both originated from the same material. In essence, the Moon is the outer cooled portion of an ancient planetary fusion. If Earth is the still beating heart of that event, the Moon is its fossilized memory. Modern simulations confirm the magnitude of the impact. Computers capable of calculating billions of variables show that the collision was so violent that part of Earth's mantle instantly vaporized, forming a temporary atmosphere of rock vapor. As this cloud cooled, it gave rise to the debris disk that would become the Moon. What was once a theoretical hypothesis is now supported by physical, chemical, and isotopic evidence. Science has reconstructed the Moon's birth with a precision that turns myth into fact. Curiously, ancient legends that spoke of the Moon as the daughter of Earth were, in a sense, correct. Peoples without telescopes or laboratories already intuited, by observing the sky, that a deep bond existed between them. What they called poetry, we now call geology. The truth is that the Moon and Earth are one entity divided into two bodies, the cold half and the living half of the same cosmic being. Even now, billions of years later, the impact continues to shape the planet's destiny. The tides, mantle movements, and even the composition of the atmosphere carry the direct consequences of that event. Nothing on Earth escapes its influence. The iron from Theia's core feeds the magnetic field that protects life. The fragments of rock and dust that form the Moon determine the tides that move the oceans. The impact did not end. It still happens invisibly in every tidal cycle, every geological pulse, every breath of the planet. Earth is therefore a hybrid world. Part of it is as ancient as the sun itself. Part comes from a planet that no longer exists. Theia lives within the planet and above it, reflected in the Moon's glow. The collision that could have meant the end became the foundation of continuity. Earth's geology is proof that even in a universe where chaos seems to reign, destruction can create balance. And so, every time we look at the sky and see the Moon hanging on the horizon, we are, in truth, looking at the remnants of a planet that created us. Theia never disappeared. It merely changed form, one part in our core, another floating in the firmament, reminding us that Earth and Moon are forever one body divided into two hearts. Long before humankind understood its cosmic origin, it already knelt before the Moon. From the first steps upon the Earth, when fire was still a new discovery and the fear of night ruled, the silvery glow of that celestial body turned darkness into mystery. It was the first light after the sun, companion of the shadows and beacon of orientation. From it was born humanity's first fascination, the desire to understand that silent, motionless presence that nevertheless influenced the seas, the harvests, and the human heart. The Moon, once born of fire, had become the mirror of the human soul. On cloudless nights it appeared colossal and near, reflecting sunlight in a soft, cold hue. To ancient peoples, that light was not merely a reflection but a living presence. The earliest civilizations recorded the moon as a deity, a celestial mother, a vigilant eye in the firmament. Peoples of Mesopotamia saw in it the god Nana, the measurer of time and protector of travelers. In ancient Egypt, it represented renewal, a cycle that died and was reborn with each phase, symbolizing eternity itself. The Greeks called her Selene, later Artemis. The Romans called her Diana. In every name, one same idea persisted. The moon was feminine, cyclical, fertile, and immortal. The moon marked humanity's first calendar. Before there was writing, there was counting of moons. Each full cycle of phases served as a unit of time, allowing the prediction of floods, rains, and harvests. It was the first natural clock, older than the zodiacal constellations, more reliable than the stars. The alternation between waxing, full, waning, and new taught humankind the concept of rhythm and passage. The moon taught humanity to measure time, to wait, and to plan. But the fascination was not merely practical, it was emotional. The moon seemed to influence behavior, mood, and sleep. The tides it governed appeared to echo in the inner waters of the human body. Ancient poets and philosophers believed that the lunar glow penetrated mind and heart, awakening dreams and madness. Hence came the word lunatic, one whose spirit changed according to the moon's phases. For centuries, people believed the moon held power over the mind, that its cycle affected fertility, births, and even states of consciousness. And though modern science explains these phenomena differently, the enchantment remains. The moon is still the mirror of the human unconscious. In many cultures, it was seen as a symbol of death and rebirth. Its face that disappears and returns each month taught humanity about life's cycle, birth, death, and renewal. Entire civilizations shaped their religious rituals around that pattern. Nomadic peoples, farmers, and navigators learned to read the sky as an open book, and the moon was its first page. It guided hunters through moonlit nights, inspired musicians and priests, and marked the sacred rhythm of ceremonies. The lunar influence also shaped the way humankind perceived nature. In the tides, people saw divine force. In the phases, the duality between light and shadow. In the craters, the face of a sleeping god or goddess. The moon united what the sun divided, day and night, warmth and cold, heaven and earth. It was the link between the visible and the invisible, the physical and the spiritual. In its presence, humanity felt both the weight of the cosmos and the closeness of the divine. When astronomy was born, the moon was its first object of study. Galileo Galilei, observing it through his telescope in the 17th century, revealed to the world that it was not perfect, that it had mountains, valleys, and craters. That discovery shook centuries of religious belief, but opened the path to a new form of reverence for truth. The moon ceased to be only a symbol and became a scientific mirror, revealing that the universe was tangible, that it could be measured, explored, and understood. Even so, the enchantment never faded. The moon remained in songs, paintings, poems, and dreams. It inspired lovers and navigators, magicians and scientists. It was the muse of poets and the target of space missions. When humankind finally walked upon its surface in the year 1969, it was not merely a technological step. It was a symbolic return to a forgotten origin. By touching lunar soil, humanity touched the body of a planet that had once been part of itself, a reunion between creator and creation. And even now, in an age ruled by technology and artificial light, the moon continues to exert its silent power. It rises and sets with the same precision as ever, observing Earth's changes without ever altering itself. It is the last link between modern humanity and the ancestral cosmos. Each time we look at it, we repeat the gesture of the first humans, the gesture of seeking meaning in the immensity. The moon within the human mind is more than a symbol. It is memory. It is the unconscious recollection of a shared past, of an impact that united destiny and matter. Humanity, when gazing upon the moon, recognizes its origin, and though it does not perceive it, every look is a return to the instant when it all began, the day when fire created light and Earth found its eternal guardian in the sky. For thousands of years, the moon was contemplated only with the eyes and the imagination. It was the distant mirror of mystery, the companion of the night and the symbol of time. But it was only when humankind lifted a glass instrument toward the sky that myth began to turn into science. The first to do so with purpose and precision was Galileo Galilei at the beginning of the 17th century. When he pointed his telescope at the moon, he discovered something that defied centuries of belief. Its surface was neither smooth nor perfect. He saw mountains, craters, and valleys, the scars of a solid and wounded body, a witness to a violent past. From that revelation onward, the moon ceased to be only an object of worship and became an object of study. Astronomers measured its phases with accuracy, calculated its distance, and understood its role in the tides. The 19th century marked the beginning of modern lunar astronomy. With more powerful telescopes, scientists began to map its surface in remarkable detail. The first lunar atlases appeared, and the shadows cast by mountains revealed the complex geography of a world without atmosphere, shaped only by impact and time. But the true leap came with the space age. In the 20th century, the moon became humanity's first destination beyond Earth. Unmanned probes were launched to photograph and measure its soil. Each mission revealed something new: the absence of air, the absolute silence, the extreme temperatures. When the Soviet lunar missions and the American Ranger and Surveyor spacecraft touched its surface, humanity's dream of reaching the heavens began to materialize. These missions gathered data, confirming what had once been only hypothesis. The moon was made of the same substance as Earth. In 1969, humankind took a step that would echo throughout history: the arrival of Apollo 11. When the astronauts descended from the module and stepped onto the lunar surface, each footprint represented not just the conquest of a territory, but a reunion with our origins. The rock samples they brought back were analyzed meticulously, and the results confirmed the giant impact theory. The isotopes found in lunar rocks were identical to those of Earth's crust. It was proof that both bodies were born from the same material, the physical echo of the collision between Earth and Theia. Subsequent missions expanded this knowledge. Apollo 12, 14, 15, 16, and 17 brought new samples and installed scientific instruments on the surface. Seismology detectors revealed that the moon still possesses subtle internal activity, deep tremors caused by contraction and by Earth's tidal pull. Other experiments measured the moon's gradual recession, confirming that it moves away by about 4 centimeters per year. Modern science has managed to measure with precision the invisible rhythm that governs the bond between Earth and its cosmic daughter. With advancing technology, humanity once again turned its gaze skyward, now with orbital instruments. Probes like Clementine and Lunar Prospector mapped the moon's chemical composition and detected traces of ice in permanently shadowed polar regions. These discoveries reopened questions about the presence of water and the possibility of future exploration. What was once a poetic symbol had now become a scientific destination. Returning to the moon is no longer a dream. It is a plan. It is the first step toward human expansion into space, and paradoxically, the gateway to understanding our most ancient origins. The latest analyses reinforce that the moon is the geological archive of the solar system. Because it lacks atmosphere, erosion, and tectonic activity, it preserves intact the records of impacts, volcanism, and cosmic events that have long vanished from Earth. On its surface rest fragments of meteorites from other worlds, and possibly even fragments of Earth itself, expelled in ancient collisions. Each speck of lunar dust is a condensed timeline. Studying it is, in part, studying the lost history of our own planet. With the help of supercomputers and advanced simulations, scientists have digitally recreated the collision between Earth and Theia. These models reveal that the impact released enough energy to vaporize rock and metal, creating a temporary atmosphere of vaporized minerals. The debris orbiting the planet merged rapidly, in just a few weeks, to form the moon. These findings confirmed what intuition had long suggested. The moon's creation was an almost instantaneous event on the cosmic scale, yet its consequences shaped billions of years of history. Today, the moon remains a natural laboratory for the mysteries of the cosmos. Planned missions for the coming decades aim to establish permanent bases, mine resources, and study cosmic radiation. But beyond exploration, there lies a deeper meaning. Every time humankind returns to the moon, it returns to its own beginning. It is like visiting the tomb of Theia, the planet that gave us form, and that in a way still lives within us. Modern science, with all its precision, has not erased the moon's enchantment. On the contrary, by understanding its history, it has deepened our fascination. Knowing that the moon was born from a devastating collision, and that from such chaos emerged the stability that allowed life to flourish, is to grasp the most beautiful paradox of the universe: harmony, born of destruction. Each scientific fact, each equation, and each collected sample reinforces a simple and profound truth. The moon is not separate from Earth. It is part of us. When humankind looks up at the sky, it sees its own past reflected in silver. Science has merely revealed what ancient instinct already knew. The moon is the mirror of the planet and of humanity. Nothing in the cosmos remains the same. What seems eternal to human eyes is only an instant in the universe's time. The relationship between Earth and the moon, so stable and harmonious, is changing as well. Slowly, almost imperceptibly, the moon drifts away from the planet that created it. Each year, the distance between the two bodies increases by roughly 4 centimeters. It's little but constant, a silent, inevitable motion that has lasted for billions of years. This recession is the price of the gravitational dance that binds them, an eternal exchange of energy that, every second, reshapes the fate of both. It all begins with the tides. The friction generated by the movement of the waters rising and falling under lunar influence transfers energy from the planet to the satellite. Earth loses part of its rotation, and the moon in return gains the push to move into a higher orbit. Thus, as Earth's days grow longer, the moon recedes. When it was born, it was 20 times closer, completing an orbit in a matter of hours. Now it takes nearly an entire month. And in the future, it will keep moving away until the gravitational balance changes completely. Over millions of years, days on Earth will become ever longer. The strength of the tides will diminish, and the oceans will grow less agitated. The energy that now shapes climate and drives the currents will slowly dissipate. The planet will enter a state of gravitational calm. One day, in a future so distant that humankind may no longer exist, Earth and moon will be locked to the same rhythm. The moon will always show the same face, as it already does, and Earth will also rotate in synchrony, presenting the same hemisphere to the moon. At that point, the dance will cease. The two bodies will be fixed with respect to one another, turning together around the sun. But that final balance will not be the end of the story. The sun, which today sustains the solar system, is changing as well. In about 5 billion years, it will begin to consume the last of its fuel and swell into a red giant. Its brightness will rise, and its diameter will expand enough to engulf the innermost planets. Mercury and Venus will vanish, and Earth, heated beyond endurance, will lose its oceans and atmosphere. In this scenario, the moon, by then much farther away, will watch from a distance as the planet that birthed it becomes a desert of rock and dust. As the sun continues to grow, the system's gravitational balance will be broken. Increased radiation and solar mass loss will alter every planetary orbit. The moon may drift even farther, or, depending on the forces at play, begin to return, pulled once more by Earth's gravity. If that happens, its approach will be slow, but fatal. In a remote future, perhaps billions of years hence, the moon could cross the Roche limit, the distance at which Earth's gravity overwhelms the moon's own cohesion. When that moment arrives, the satellite will shatter into millions of fragments, creating a new ring of rock and dust around Earth. The system will end as it began, wrapped in debris. Before that, however, Earth will undergo profound transformations. As days lengthen, the slower rotation may weaken the magnetic field. With gentler tides, biological cycles will change. The moon will still influence the oceans, but its presence in the sky will look smaller. Moonlight will be more distant, colder, and the nights a little darker. Even so, the bond between the two bodies will persist. No distance can erase the mark the moon has left on Earth and on the life it helped to create. Science also envisions a future of exploration and coexistence. Before the sun unravels this harmony, humankind, or its descendants, may turn the moon into a new home. Its surface, rich in minerals and free of atmosphere, is ideal for observatories and future colonies. Ice found in polar craters could be used to produce water, oxygen, and fuel. What began as a shared origin may become a conscious partnership. The moon, once a cradle, could become a refuge. And when the sun finally dies, Earth and moon may still orbit together around a dead star. a cold, silent white dwarf. In that final scene, the glow of moonlight will have disappeared, and the two bodies, now frozen, will keep circling side by side, forever bound in a dance without light. They will be mute witnesses to the end of the solar system, holding in their rocky layers the record of a story that began in fire and ended in silence. But even that destiny does not erase the meaning of what has already happened. The moon is the permanent reminder that balance can arise from destruction and beauty from chaos. It is the reminder that nothing in the universe is permanent, only the cycle. The same force that created the moon will continue to act on unimaginable scales, remaking worlds, spreading dust, reigniting stars. And when other planets and other moons are born from new impacts, the story will repeat itself in different forms, but with the same essence, the universe recycling itself. Thus, the future of the Earth-Moon system is also the future of existence itself, a cycle of birth, separation, and transformation. What we see in the sky today is only a stage in an endless process. The moon, born of fire and now lighting our nights, will carry on through the cosmos, bearing with it part of Earth, part of Theia, and part of us. The universe rarely creates without destroying, and rarely destroys without creating. The impact between Earth and Theia is the perfect example of that duality. From the collision that could have annihilated an entire planet came the harmony that would make life possible. Everything we are, the soil beneath our feet, the air we breathe, the rhythm of the tides, and even the balance of days, comes from that meeting of fire and silence. The moon is not merely a body in the sky. It is the vestige of a cosmic act that transformed chaos into balance and chance into destiny. When we look up at the sky and see the moon hovering over the horizon, we are witnessing the result of one of the greatest metamorphoses in cosmic history. The energy that created it still pulses within our planet. The iron and nickel from Theia, fused with Earth's core, feed the magnetic field that shields us from solar radiation. The tides, guided by its presence, continue to move the oceans and regulate the climate. The impact of Theia was not merely an event of the distant past. It is an active, ongoing force that still shapes Earth with every dawn and every sunset. The moon is the mirror of origin, the reminder that stability is born from imbalance and that time transforms destruction into harmony. Every crater on its surface is a scar of primordial chaos, but also proof of the universe's resilience. It carries within it the history of our own matter. The dust that composes its body is the same that forms our mountains, our cities, and even the calcium of our bones. We are made of the same impact, the same collision that ignited the silvery glow ruling our nights. That legacy goes beyond geology and biology. It is also philosophical. The impact of Theia reminds us that the universe follows not a logic of perfection, but of transformation. Every catastrophe is an opportunity for reorganization. Every chaos hides the seed of stability. The moon is the supreme symbol of that principle. Born from destruction, it became the emblem of calm. It is living proof that the universe is an artist painting balance with the colors of collapse. The collision between Earth and Theia also redefined the concept of origin. For a long time, humankind believed that birth was an absolute beginning. Science revealed it as only a continuation, the outcome of countless prior events. The moon is Theia's continuity, and Earth is the testimony of survival. Together they show that nothing is lost, everything transforms. Even what seems an absolute end is, in truth, the beginning of a new cycle. The cosmic impact that shaped our world created more than a satellite. It created a bond, a link that transcends physics, for it united two bodies in an eternal relationship. The moon orbits around Earth, but also within the human mind. It inspires art, science, mythology, and faith. It is the symbol of the passage of time, of rebirth, and of awareness. It silently represents the triumph of harmony over chaos. When night falls and the planet is covered in darkness, the moon rises to remind us that every shadow hides a spark of light. The fire that once destroyed two worlds is the same that now illuminates our nights and defines the rhythm of our lives. Every rising tide, every changing season, and every breath we take is a direct consequence of that primordial moment. The moon is not outside us. It lives within the planet, and the planet lives within it. And when the distant future arrives and the sun fades, when Earth and moon orbit together around a dead star, The echo of that impact will still remain. There may no longer be oceans, continents, or life, but the rocks will still hold the memory of the day when fire gave birth to light. The moon will endure as the eternal witness of the moment when destruction became creation, the instant when chaos decided to build a home for life. The legacy of that impact is therefore the legacy of existence itself, the certainty that the universe is motion, and that every ruin can become a beginning. The moon was born from fire, and fire from silence. And in this endless cycle of collisions and rebirths, the cosmos continues to remind us that even the greatest tragedies can become beauty. And so ends the story of the impact that created the moon, shaped the earth, and gave birth to everything we know. A cosmic encounter between fire and gravity that transformed destruction into balance, chaos into life, and silence into light. Every night, when the sky opens and the moon rises among the clouds, remember, that glow is not only in space, it also lives within you. The moon is the reflection of time, the mirror of our origin and the guardian of our planet. Everything that exists, from the simplest drop of water to the deepest human thought, carries the mark of that primordial impact. When we look at it, we are looking into the past, and when it looks back at us, it is as if the universe itself were reminding us where we came from, and how unlikely it is that we are here at all. If you've made it this far, it's because you also feel that same curiosity about the mystery of the cosmos. So tell me in the comments, where are you listening from right now? Leave your comment below. I'd love to know how far the message of this video is reaching. Before you go, leave your like, because that really helps the channel continue bringing stories like this one. Subscribe, so you don't miss the next videos on the channel, and turn on the notification bell, so you're always alerted whenever a new episode comes out. See you in the next video.